everybody, the next lecture from this course will be about basics of object-oriented programming. Here we're going to review fundamental principles of object-oriented programming. We're going to take a look at inheritance, abstraction, and encapsulation as well. So let's begin with fundamental principles. So the first fundamental principle is inheritance, which is for inheriting members from parent class. We have abstraction, which is for define and execute abstract actions. We have encapsulation, and its point is to hide the internals of a class. And we have polymorphism. Polymorphism is to access a class through its parent interface. Here an example of inheritance. What I have is to the top a class person with email and name properties. Then it's being inherited by teacher, student, and employee. Teacher has an extra property subject, student has student ID, and employee has employee ID and job title. Then teacher is being inherited by school teacher with school property and university professor with university property. Employee on the other side is inherited by senior employee with property of years experience. And now what's the thing here? The thing is that because student, employee, and teacher, all of them are inheriting person, then they're inheriting its properties as well. So employee has employee ID, job title, and he has as well email and name. And this email and name, they are also for student and for teacher as well. If we review, let's say, for example, university professor, what he has as properties? Well, it has university, which is coming from university professor class. It has subject, which is coming from teacher class, and it's coming from there because we inherit it. Then we have email and we have name as well, which are coming from person class that we inherit. So classes define attributes and behavior, fields, properties, methods, etc. Methods contain code for execution. For example, we have class labyrinth with public sales count, which is number. Interfaces define a set of operations, and there are empty methods and properties left to be implemented later. Here an example, we are saying interface iFigure, which has a method draw, which is actually void. The point here is that interfaces, they're defining only what implemented classes will have. So inside interface, we don't have the implementation of method, we just define it. And after that, when we inherit this interface from some class, we have to implement it. Standard practice is for interfaces, for naming, to place I in front of the name. So inheritance allows child classes to inherit the characteristic of an existing parent class. So attributes, which could be fields and properties, and operations, which are methods. Child class can extend the parent class, and they can also add new fields and members and redefine methods, for example, modify the existing behavior. And a class implement an interface by providing implementation for all its methods. So let's see what types of inheritance we have. When we have derived class and base class or parent class, this is called inherit. This is basically the terminology. If we have class and interface, then we say that class implements the interface. And if we have derived interface and base interface, then we say that derived interface extends the base interface. What are the benefits of inheritance? Well, inheritance has lots of benefits like extensibility. We have reusability. It provides abstraction, so we're following object-oriented programming principles. It eliminates the redundant code, and also use inheritance for building is-a relationships. For example, dog is an animal, and dogs are kind of animals. Don't use it to build has a relationship. Dog has a name. Dog is not kind of name, and that's the important thing which you have to remember. So you build it for is a, not has a relationship. So inheritance implicitly gains all members from another class of fields, methods, and properties, and some members could be inaccessible or hidden. The class whose methods are inherited is called base or parent class. and the class that gains new functionality is called derived or child class. Here's an example of inheritance. I have one class person, which is actually the base class, and after that we have two derived classes employee and student. Person has name and address, employee has company and salary, and student has school. So after derived classes inherit the base class, they will receive these properties as well, so you can access them. Another example of class hierarchies. For example, instance leads to hierarchies of classes and or interfaces in an application. For example, I have game, but inside that game I can have single player game or multiplayer game. Single player game could be Minesweeper or Solitaire, and multiplayer game could be board game or something else. And after that, board game could be broken down to chess and backgammon, for example. So you can see a real example of how things are broken down and how the hierarchy is built of classes and interfaces. So interface in TypeScript, a class can inherit only one base class. For example, IO exception derives from system exception and it derives from exception. A class can implement several interfaces. List from T implements iList from T, iCollection from T, and iNumerable from T. And an interface can implement several interfaces. iList from T implements iCollection and iNumerable. How to define interface? Well, we need to specify the name of the base class after the name of derived using extends. So I have the parent class, which is class shape, and then to inherit it, I must say class circle extends shape. And that's how I'm making the inheritance. So you can see that it's pretty easy, just one word and the name of the class. So we use the keyword super to invoke the parent constructor. If I have a constructor with x and y number receiving, and here I want to call the constructor of shape class, not the circle one. I want to call the shape class constructor so I can reuse the code. Then I'm using the keyword super and I'm passing the parameters. Simple inheritance example. Well, I have class mammo with constructor that receive a parameter public age, which is number, and here I set it. Then here I have a method sleep, which is void, and console.log on some string. Then I have class dog, and this class dog extends mammo. But dog can have breed, let's say, and age. So to reuse already constructor, which is coming from mammo and it's receiving the age number, then I can say super from age. And here I'm just setting this.breed equals breed. After that, I can add an extra method with tail, which is void and it's printing something on the console. What about access levels? So here we come again to access modifiers in TypeScript. So public access is not restricted because everybody can access it. Private access is restricted to the containing type, and protected access is limited to the containing type and types derived from it. Here, an example of inheritance and accessibility. So I have class creature. This creature has protected field name, which is string, and it has getter for this name, which returns that value. After that, I have two methods. One is protected vogue, and the other one is private talk. So let's see. I can say class mammo extends creature, and then super.vogue can be invoked here because this is protected. But super.talk cannot be invoked because it's private and it's accessible only from creature class. This .name can be read but cannot be modified here. So I can read it because I have the property with getter, but I cannot modify it because I don't have setter property. So class doc extends mammo, and now we have private breed, which is string, and some public getter, which is for breed. And here super.talk cannot be invoked because it's private. Let's continue with the examples. I'm defining a new instance of doc and I'm saying let Joe, which is from type doc, is equal to new doc and with two parameters. Then I print on the console jaws.breathe, and now let's see. jaw.walk is protected and cannot be invoked from here. jaw.talk is private and again cannot be invoked from here. If you try to change its name to modify it to Rex, then name cannot be accessed, and if you try to modify breathe, you cannot modify it. So you cannot modify it because we're missing set of breathe. Name cannot be accessed here because it didn't have the property. So here we have getter, but we're missing the setter. So some important aspects of inheritance. In TypeScript, there is no multiple inheritance. Only multiple interfaces can be implemented. Static members are also inherited. Constructors are not inherited. Instance is a transitive relation, and if C is derived from B and B is derived from A, then C inherits A as well. So we have A, B, C. And let's say if C is derived from B and B is derived from A, then following this logic, C is derived from A as well. Some important features. When a derived class extends its base class, it can freely add new members, cannot remove derived ones, and declaring new members with the same name or signature results in an error. A class can declare abstract methods and properties as well, and derived classes can override the implementation of these members.